Alright, so this is question 13, 6b. The question reads, a car is traveling at 100 kilometers an hour on a bearing of 120 degrees, and a motorcycle is traveling due west at 80 kilometers per hour. We want to find the velocity of the motorcyclist relative to the car. So let's look at our relative velocity formula. That is, if you have A relative to B, you'll have the velocity of A take the velocity of B. So now we're going to take that and we're going to turn it into our motorcyclist and our car. So we have the velocity of the motorbike relative to the car. That's going to be the velocity of the motorbike take the velocity of the car. So let's draw a diagram here just to explain exactly what that's about. So I've got my x and my y axes. That's north there, east, south, west. And I'm going to draw in the car. So the car is traveling at 100 kilometers on a bearing of 120. So 120 is roughly there. So that's my car right there. Okay? And my motorbike, or my motorcycle, is going to be due west. That's west. It's going to be V motorbike. So now the question says to find the relative velocity. I'm going to take the velocity of the motorbike, take the velocity of the car. And taking is the same as adding a negative vector. So my new diagram should look a little something like this. So we still keep our velocity of our motorbike. That's the same, that hasn't changed at all. And now we're going to take our velocity. So basically it's going to change the direction of the car going that way. So what we're trying to find is our resultant. So this guy there. So this guy here is this guy there. Alright? Oh look, well I know that that's 80 there, and that's 100. Do I know my angle? Well, if that's 120, that's going to be 70 plus 90. Sorry, that's 120. This is going to be 60 plus 90. That's the right angle. So my angle in between there is 150. So I can use the cosine rule. So the cosine rule, we're going to go 80 squared plus 100 squared. Take 2 times 80 times 100 times the cosine of 150. We can pop that into a handy dandy calculator, as they say. Alright, so that's a square there, because we're going to have to do a little square root. Alright, so our magnitude of our velocity is going to be 173.94 kilometers per hour. So the velocity has a magnitude and a direction. So we need to find the bearing. We need to find the bearing, which is basically, oops. Sorry about that, guys. That was the working out from before. So the direction is going to be the bearing of this right there. Okay? Well, to find this, I first need to find this angle here. We'll call that angle theta. Let's solve for that angle. So I can use the sine rule. I can say, well, I've got sine theta over 100. That's going to equal, so over 100, that's this blue guy there, that's 100 there, equals sine 150 over our newly found value of 173.94. Alright, pop it in the class pad, you get theta as 16.7 degrees. So using a little bit of trigonometry, we're going to add that over to 270. So 16 plus 7 plus 270. That's going to be 287. Alright? Remember, bearings have no decimals. Right, so that's your magnitude, that's your bearing, and that's question 13. Thank you.